All right, let's see. Okay, hello everyone. My name is Mete Atamel. I am a developer advocate at Google, and I talked at TDC before a few times in different places. And it's been very long, 2.5 years away from in-person conferences, but I'm glad that I'm here today with you. Let me set my clock so I don't talk too much. All right, so what we're going to talk about today is service orchestration and service orchestration best practices and patterns. And my presentation is already on speaker deck, so if you want to get the presentation after the talk, feel free to get it from this link. And if you want to follow me on Twitter, this is my link as well. And I will share these links at the end of the presentation as well. So first, let's talk about what I mean by service orchestration. And then I want to talk about the best practices, okay? So what do I mean by service orchestration? Well, service orchestration tries to answer this one question. How do you organize a group of microservices to cooperate towards a common goal, okay? You know, if you remember, if you've been doing software development for a while, we used to create these big monoliths, right? We used to put everything together in a big monolithic kind of application. Now, over the years, we learned that this is not the best way of organizing our software, and we started breaking down this monolith into smaller microservices. Now, once you do that, you get some benefits, but at the same time, you also start getting some other issues. And one of those is, how do you group these microservices, and how do you get them cooperate towards a common goal? How do you get them work together in a harmonious kind of way, right? So that's what service orchestration is about. Now, there's some options that you can choose in terms of how you organize your microservices. And the first one that I want to talk about is what I call service-to-service calls. So let's imagine that you're building an e-commerce application, you know, and in this e-commerce application, you're trying to sell some, you know, items to your customers. Now, one way of organizing your microservices is what I call chaining. So in this model, maybe you have a front end that receives the requests from the users. Then maybe you have a payment processor that processes the payments. Then maybe you have a shipper that figures out the details of shipments to the users. And then maybe you have a notifier that notifies the user that, you know, the things are being shipped and delivered and so on and so forth. And of course, in a real application, you have many more services probably, but I'm trying to simplify it here a little bit. So in this model, what you have is, you know, each service just calls the next service in the chain. So the front end knows about the payment processor knows about the shipper, so on and so forth. So it's service-to-service calls. Now in this model, the pros is that the positive thing about this model is that it's very easy to implement, right? All you need to worry about is, you know, this is service A, it needs to call service B, and the service B has to call service C. So it's very easy to think about, it's very easy to implement. On the other hand, you are creating too much coupling between your services. Now, if you need to change a service in the middle, let's say service B, now you need to think about service A and service C as well, right? Because any change in B might have effects on the service calling B, and any change in B might also affect the service that's being called from B, right? So you're already creating this too much coupling between your services. Secondly, each service can be a single point of failure. So let's say the service in the middle doesn't work, then that kind of breaks the whole chain, right? So all of the services, they have to work together, and they have to work all the time for things to work. And that's not a good place to be, right? Each service needs its own error, retry, and timeout logic. So let's say one of your services goes down once in a while. What you can do is you need to do some kind of retry. You need to call that service again. So that logic has to be implemented. Or if a service throws an error, you need to handle that error. So that logic also has to be implemented. So you have to do this error and retry handling in each service. And for me, the most important problem is that who ensures that the whole transaction is successful, right? I mean, each service might be doing their own bit, but who makes sure that this transaction that spans multiple microservices is actually successful? And there's actually a pattern called Saga pattern that helps for this that we'll talk about. So as you can see in this simple service-to-service call, it's very easy to implement, but it already has a lot of problems that you need to think about. So it's not so easy maybe, right? Now another option that you have is to use events. And this is also known as choreography. And in this model, you still have your services, but instead of your services calling each other directly, they communicate via events indirectly. So the front end will receive the request, then it will just say, okay, I received this request, and it will create an event called maybe order request event, and it will send that event. There's typically a message broker receiving these events. Then it will look who is interested in this order received message. That's the payment processor. Then it will route that message to the payment processor. Then the payment processor will do its payment processing. And once it's done, it will send another message type, payment processed, that will go to the message broker, and so on and so forth. Now in this model, the services, they don't know about each other. They don't care about each other. They just communicate indirectly through different events. And if you use some cloud providers like Google Cloud, AWS, or Azure, there's services like EventArc, EventBridge, EventGrid, or also in open source like Kafka and RabbitMQ. So there's a lot of technology out there already that helps you to use event-driven architectures. Now, of course, everything has pros and cons. So in event-driven architectures, the pros is that, first of all, your services are loosely coupled. They don't know about each other, and that's a really good thing because you can change your services independently. Your services can be changed and scaled independently. So if you need to change one of the services, you don't really need to worry about other services so much because they're not calling each other directly. There is no single point of failure. So let's say one of the services goes down. The rest of the services, they can still receive messages and they can still emit messages, right? And the service that's been down, it has a queue usually, and the queue will have more messages that needs to be processed later. But this doesn't break the whole chain. I mean, your services can still function at some level, and that's a good thing as well. And events are very useful if you need to extend your system. So if you need to add a new service, all you need to do is that you need to deploy that service, and then you need to configure what events that service has to get, and that's it. You don't need to change the rest of your architecture to add new services. On the other hand, event-driven architectures are difficult to monitor because you have all these events flying around, and there's all these different types of events. So if something goes wrong, it's not immediately obvious what went wrong. So it becomes a little bit hard to trace and a little bit hard to monitor your system. These errors and read times and timeouts logic that I talked about before, you still need to think about them, so they're still hard to do. The flow of your application is not captured anywhere, so the flow of the application just kind of happens in an indirect kind of way, but there's no single place that you can go and say, okay, this is how my system should work, this is how the events should flow. You can't really point to a single place for that. And this problem that we had before, this, who ensures that the whole transaction is successful, is still a problem, and you still need to think about that. So events help for some of the things, but you still have other things to worry about. So it doesn't solve all your problems. And if you imagine a more complex scenario, for example, in an e-commerce application, you probably need to talk to a database, and depending on your stock, you probably want to take some action. If you have no stock, maybe you need to call a supplier API, and then maybe you need to update the database again, and maybe you need to use a third-party API to notify the user. So in this flowchart, it's kind of obvious what should happen, but taking this and making it an event-driven architecture, it's not so easy, actually. So even though this looks easy, doing this in an event-driven way, it's not that easy. Another option that you have is to use a central orchestrator. And in this model, you still have your services, but you also have a central orchestrator, an external service, where you define how your calls should happen. So the orders will come into the front end. Then the front end will start the orchestration. The orchestrator has a list of services to call, and it will call the payment processor first. It will get the result. Then it will pass that result to the shipper, and it will call the shipper, and it will get the result, and so on and so forth. Does this work, by the way? Yes. OK. And again, if you look at Google Cloud, there's workflows. If you look at AWS, there's step functions. On Azure, there's logic apps. So there's technologies out there that help you to build this orchestrator, right? So you don't need to build it yourself. There's actually services that you can use. Now, the pros and cons of this central orchestrator is that now you have a central place to capture the flow of your application, OK? And since you can capture this flow, this can be source controlled, and it can be versioned. And this is really useful, because if someone comes to you and says, how should my system work? Now, there's a place you can go and actually show people how it should work. This orchestration definition is your definition of how things should work. And in orchestration, there's distinct steps. And each step is very obvious what should happen in that step. And if something goes wrong, it's very obvious, like, this step failed. So you can actually monitor when things fail much easier than event-driven architectures. These errors, retries, and timeouts that I talked about before, now you can centralize them. So you don't have to implement each of these policies in each service. Instead, you can implement it in the central orchestrator, and that simplifies your microservices. And your services are still independent, right? So they're still deployed independently, but you kind of bring them together into a temporary orchestration that you define. On the other hand, your orchestration service, it's something new to learn and maintain. So it's another thing in your architecture that you need to worry about. It can be a single point of failure, so you need to make sure that your orchestrator is resilient and redundant. And you are losing a little bit of flexibility by using an orchestrator, because if you need to deploy a new service, then you need to deploy the service, but you also need to change your orchestration and deploy your orchestration as well. So it becomes a little bit harder to change your architecture if you're using an orchestrator. And this problem that we have is still there. So if something fails, you still need to take an action. Orchestrator doesn't fix it for you. And again, here, the Saga pattern will help, and I'll talk about that in the rest of the presentation. All right, so this is what I mean by service orchestration and some problems around it and some of the options that you have. But now let's look at some patterns and best practices that I've seen in service orchestration. Well, first of all, this is not a pattern, but it's more like what you should do is that you need to make a conscious choice for your architecture, right? For example, if you have a simple architecture with a handful of services, and if these services, they don't really change that much, then maybe it's OK to use direct service calls. You don't need to introduce the complexity of eventing. You don't need to introduce the complexity of orchestration. Maybe it's OK just to make them call each other directly, because they're just a handful of services, and they don't really change that much, so you don't need to worry about changing your code so much. On the other hand, if your services are not closely related, they just work independently, they are executed in parallel, but in no certain order, and services can exist in different kind of contexts. So if you have this loosely coupled kind of architecture, then that's when I am starting to think about event-driven architecture, because things should be loosely coupled, and that's what event-driven is useful for. And if your services are closely related, they are usually deployed together, and they are executed in a certain order. And if you can describe your architecture in a flowchart, and you want to kind of maintain that information, then maybe a central orchestrator is a better choice, right? And there's no right answer, too. And there's no, I can't say one is better than the other either. It's all pros and cons that I described. But make sure that you go through this exercise and make sure you choose an architecture that's best for you. Don't just let your architecture happen because it just randomly happened that way, right? Make a conscious choice about your architecture. Okay, one pattern that I see quite often is what I call event-driven orchestration. So I have this example on GitHub that you can check out, and it's an image processing pipeline. And in this pipeline, the idea is that users save some images to a bucket, and then there's a number of services that process that image in order. This service called filter service, it filters images using machine learning. Then the labeler extracts the labels from the images using, again, machine learning. The resizer resizes the images to a certain size. And finally, watermarker takes the resized image and takes the labels from this function and creates a new image with the watermark on top and saves to an output bucket. Now, in this architecture, first I put these services, these functions, into an orchestration. And the reason for this is that these services, they always go together. I always deploy them together. And they also need to be called in this order. First, I need to call the filter, then I need to call the labeler, so on and so forth. So because of that, orchestration is perfect for this for these functions, right? So I put them in orchestration. But then to trigger this orchestration, I use events. So when the user saves a file, that file gets picked up by EventArc, which is a service on Google Cloud for eventing, and gets passed to the workflows, right? So the trigger of the orchestration is event-driven. So we're combining orchestration with event-driven architecture. And I see this quite often. And just to show you how this looks actually in code, first we need to define our workflow. And this you can do in YAML or JSON on workflows. And this might be a little bit hard to see, but let me try to make it bigger. So basically, we are saying that this is my orchestration, and I'm receiving an event, which will be the user saving the file. Then I log the event. Then I extract the information from the event, so the file information. And then we do the steps that I talked about. So we call the filter function and save the response of the filter function. Then we check the safety from the filter function, so if it's safe or not. If it's safe, we go to label. If it's not safe, we end our orchestration. Then if it's safe, we call the label function. And then we call the resize function. And then finally, we call the watermark function with the input from resize function and also input from the label function, right? And then finally, the return is just the HTTP code from each functions. So that's how you can define your orchestration and what should happen in what order. And then to connect this to events, all we need to do is create a trigger. So I'll just show you that here. So the trigger is, it's an EventArc trigger. And we are basically saying that when we define some filters, so we are saying that when a user saves an image in this bucket, and the type of the event is object finalized, meaning it's a new file, then when that happens, send this to this workflow. So call this orchestration, basically. So by creating this trigger, you're making this connection from events to orchestration. So this event-driven orchestration is something I see quite often. Second thing is about handling errors with retries and Saga pattern. Again, let's look at an example. Let's say you have an order service that receives some orders, and when you receive an order, you create a pending order. So it's a new order, basically. Then you have a customer service, another service, where you check whether the user has credit. So you call this reserve credit function, right? And then if the reserve credit is successful, then we call the order service again, and we approve the order. So that's the happy path. And then if you cannot reserve the credit, then there's also another path called reject order, because you need to reject order if the user doesn't have any credit. Now, there are a couple of things that can go wrong here. The first thing is that the customer service, it might be flaky, it might not work all the time. So maybe once in a while, it just throws an error. So when that happens, one simple thing that you can do is you can apply a retry policy here. So when the order service calls this customer service, it can call one or more times to recover from this failure, right? So that's the retry policy here. And then the second thing that can fail is that maybe the user doesn't have credit. So when that happens, you need to take a compensation step. And that's what's also known as Saga pattern, right? So if everything is successful, then you go this path. But if something goes wrong here and that you cannot recover from, then you need to take a compensation step. So that's the reject order, that's the Saga pattern. So you need to think about these things. You need to think about when to apply the retries and when to apply a compensation step using the Saga pattern. Again, I have this example. I just want to show you how this looks in orchestration. So if you look at the definition of the orchestration, you will see that, again, we are doing this create the pending order by calling the order service. Then we try to call the reserve credit here. But then there's this retry part here. This is the important part. So what this says is that call this customer service to reserve the credit, but apply this retry policy, which is default retry policy that Workflows has. And it will retry 5 times when it sees HTTP 503. So if the service is unavailable, it will try 5 times before it concludes that it's not working. And then, of course, at some point when the user doesn't have credit, you need to handle it as well. So then we have this except clause as well. And in here, we check the error that we are getting. And then we are saying that, OK, if you receive a 500, which is internal server error, then we're going to reject the pending order. OK? So that's the compensation step. That's the Saga pattern. So if we do that, then we call reject pending order. And then we will call the order service with order ID, and we'll just reject the order. Otherwise, we'll approve the order and return the order, right? So that's also a common pattern I see, the retries and Saga pattern. Another pattern I see is sometimes you have an orchestration, you're running some steps, and you just want to pause and wait for something, right? You might want to wait for an HTTP call, or maybe a user needs to approve that orchestration, or maybe you also want to wait for an event, like a pops-up message or something else. So instead of letting your orchestration poll, you can actually pause and wait. So there's 2 examples. It's hard to see here, but I'll just describe it here. You basically start your orchestration. This is an orchestration that translates messages. You do the translation. Then you create an HTTP endpoint and just wait. And then the user gets the translation and approves that translation and says, OK, this looks like the right translation. And then this will go back to your orchestration, and then your orchestration will continue. So here, you're waiting for HTTP calls. And then in this second example, we are waiting for events. So your orchestration starts, then it creates a callback, it waits, and then when something happens here, a user saves a file or a user sends a message, then this will call your orchestration, and your orchestration will continue. So this pattern of orchestration happening and pausing and waiting for something and then continuing, it's a really important pattern, and it really solves a lot of complicated use cases by using this pattern. And you can see the examples here on GitHub that I have. All right, another pattern I see is parallelize when you can. So in orchestration, it's steps, right? You call step A, step B, step C, step D. And you might think that everything has to happen in sequence. Everything has to happen one after another. But actually, you can parallelize these steps. If these steps, they don't depend on each other, you can run them in parallel. And there's an example. We have this job, BigQuery jobs. It's basically a job that runs some queries against a database, Wikipedia. And if you run these queries sequentially, so one after another, then each query takes 20 seconds, right? And because of that, 20 times 5, the whole thing takes 1 minute. But if you take these queries, and they're independent, and run them in parallel, then they take 20 seconds, because they can run in parallel. And to do this, it's really easy. If you look at I just want to show you quickly the definition of the parallel. So I had these two versions, the serial and the parallel, but if you look at the parallel one, you will see that we have our tables that we want to query, and then we for loop over the query and say, okay, for each table, run this query for this table, basically. And then we put this whole thing in parallel keyword. When you do that, basically every iteration of the for loop happens in parallel instead of one after another. So by just putting this simple keyword, you are running things in parallel. And you should do that if you can. When things are independent, you should run them in parallel. All right, another pattern is combining serverful workloads with serverless orchestration. So what I mean by this is that sometimes you cannot use serverless functions or serverless containers. And the reason for this is, maybe the serverless function has a timeout limitation. Usually the functions they need to run within 5 to 10 minutes, or maybe some memory or CPU limitation that these serverless services have. And at that point, if you need to run a long-running kind of job, you probably want to use a machine, a virtual machine, with the CPU and the memory that you need. But what you can do is that you can use orchestration service, like workflows, for example, to automate the lifecycle of that VM, right? So you use orchestrator to create the VM with the CPU and memory you want, start your job that you need to run on the VM, get the result when it's finished, then delete the VM and return the result. So this way, you're using servers that you need, but you're using orchestration to automate those servers. So in a way, you're doing serverless without the user having to know that you're running VMs. And I have an example here with this link that you can check out how to do that. All right, another pattern. I know there's a lot of patterns, but I'm trying to go through them as fast as I can before the time runs out. Again, if you need to run long-running batch jobs, you can again use serverless orchestration to manage that. And I have this example to take screenshots of web pages with something called Cloud Run Jobs. So Cloud Run Jobs, it's a batch service that allows you to run containers in parallel. And in here, we are again using this event-driven orchestration pattern. When the user saves a file to a bucket that has the definition of a job, this gets picked up by EventArc, that goes to workflows, and then workflows looks at the job. The job has the list of URLs that we want to scrape. Then it says, okay, job 1 has 3 URLs. Then it will create 3 Cloud Run jobs to run them. And these Cloud Run jobs will go and fetch the websites and download the screenshots of those websites, and it will save it to the cloud storage bucket, right? So in this model, there's a few things. First, we are using event-driven orchestration. Secondly, we are using Cloud Run job service to run batch jobs in parallel. And then third, we are using workflows to manage that, right? So in the end, everything is end-to-end serverless. You don't have to worry about machines or anything like that. But you're using the right service for the right job. So workflows for managing the orchestration, Cloud Run job for the batch jobs, and EventArc for eventing part of it. So again, I have examples on GitHub for this. And there's also another example that uses batch service, which is another service on Google Cloud that lets you basically run batch jobs on virtual machines. So you can use that as well instead of Cloud Run jobs. All right, another pattern is using GitOps to manage your orchestration. So you probably know GitOps from your code. Usually when you want to change your code, you don't just change it in the production. What you usually do is that you create a branch, like staging branch, for example, and then make the change there, run some tests, and then once those tests are successful, then you merge the change to the main branch, run some more tests, and then you deploy to your production, right? Usually that's what you do with your code. Well, you can do something similar for your orchestration as well. So you can again, on the staging branch, change your orchestration YAML, then deploy a test workflow, then test it with using some scripts, then deploy the final staging workflow. Once you're happy, merge that to the main branch, do the same thing again, deploy a test workflow, test the test workflow, and finally deploy your production workflow. So this whole idea of GitOps, it doesn't really just apply to code, it can also apply to your infrastructure and orchestration as well. And I show how to set this up with Cloud built on Google Cloud. And finally, you need to plan for multi-environment deployments. What I mean by that is that you're not going to have just production workflows. You're going to have staging, test, production, so many environments. So you need to think about that from the beginning, and you need to have infrastructure in place to deploy your workflow in different environments. And there's two different ways of doing this that I show in the sample. One is to author your workflow. And let's say your workflow needs to call some URLs that can be staging URLs or production URLs. So you can author your workflow, and you can have URLs as runtime arguments. So you have a single workflow. And when you execute the workflow, you can pass in these URLs as like staging URLs or production URLs. So that's one approach that I show here. And the second approach is you can have your workflow with placeholder URLs. And then you can have something that replaces those URLs. So you can use either Cloud built or something like Terraform that replaces the URLs for staging, replaces the URLs for prod, deploy these workflows as separate workflows, and then execute the workflow in staging or production. And there's pros and cons of each approach. So if you go to this link, I explain how to set this up and also what are the pros and cons for each approach. Okay, I think I'm running out of time, and I think that's it. So thanks very much for listening. If you want the slides, it's on speaker deck. If you want to ask questions, I'm around, so feel free to reach out to me. As I said, I'm very happy to be back to TDC in person, so hope you enjoy the rest of the conference. Thanks very much for your attention. Thank you.